Number 17. What initial backward force do the car's drive wheels apply to the road? So first of all, this force is coming from the rubber band, and the rubber band is transferring this force to the string, and then the string transfers this force to the drive axle, and the drive axle is attached to the drive wheel, and the drive wheel pushes the road. So in the beginning, the rubber band is stretched to here, and it applies a 12 Newton force right there. So there's 12 Newtons of tension in the string, which means the string applies a 12 Newton force tangentially to this drive axle. It's got a little tiny radius that creates a torque on the drive axle, and it creates a torque on the wheel, and that torque transfers another force at the outside of the wheel. Now that other force is going to be smaller because this new radius is much bigger. So here are the numbers. This is just showing a large version of this. The torque equals the force times the radius. So 12 newtons, that's the initial force, and this is the axle radius. That's the radius we have to use in the beginning. It's this little tiny thing right here, because this is where the force is being applied. This is the only force we know about in the beginning, this 12 Newton force. So that's going to tell us the torque on the drive axle and on the wheel because they're fused together. That's 0.036 meter newtons. This torque exists throughout the wheel, so the torque, again, same torque, equals the force on the road times the radius of the wheel. And I've just substituted numbers in here. 0.036 meter newtons, that's the torque, equals the force on the road, times 0.03. 0.03 is the wheel radius. I forgot to point out that the drive axle radius can be found right there. So when you solve this, you want to know the force on the road. Divide this side of the equation by 0.03. That gets rid of these two. Divide this side of the equation by 0.03. And when you do, you get 1.2 newtons equals the force on the road.